Hello everyone. Today we're going to talk about how to calculate equilibrium constants when you're given information about other related reactions. First, a quick review of what we've already talked about with equilibria. A reaction is at equilibrium when the forward and reverse reactions are occurring at the same time and at the same rate. The equilibrium constant K, or KEQ, is a ratio of the product concentrations to the reactant concentrations when you are at equilibrium. So for example, for a very generalized reaction as shown below, the equilibrium constant is written there, where the product concentrations are raised to their coefficients, and they are all over the reactant concentrations raised to their coefficients. A quick reminder that solids and liquids are not included in equilibrium constants. So let us consider a reaction where we know the equilibrium constant. Let's say for some reaction A2 plus 2b yields 2ab, we know that the equilibrium constant is 3.4 times 10 to the negative 2. Determine the equilibrium constant for the reaction shown below, which is 1/2 A2 plus b yields ab. You'll notice this is the same reaction, but the coefficients have been cut in half. So they must be related to each other. Let's write the expressions for the equilibrium constants for both reactions. So for the first one we were given, where we happen to know what the equilibrium constant is, we know that the expression for the equilibrium would be AB squared all over concentration of A2 times concentration of B squared. For the reaction where the coefficients are halved, K would be concentration of AB all over concentration of A2 raised to the 1/2 times concentration of B. These look very similar, but you'll notice all the powers are different. In order to calculate K in this situation, we would need to take the initial one we had, the 3.4 times 10 to the negative 2, and raise it to the 1/2 power, aka take the square root of it. So, a general thing that you should know how to do. If you are presented an equilibrium constant for a reaction, and you then see a reaction where you have multiplied the coefficients by some constant, the new equilibrium constant is raised to the power of whatever you multiplied by. For example, if you triple a reaction, you need to raise the equilibrium constant to the 3rd power. A quick note, if you reverse a reaction, that means that you are doing the inverse for the equilibrium constant, aka you're technically raising to the -1 power. So with that in mind, let's take a look at a reaction written as a series of steps. Let's say the reaction A plus 2b yields C plus 3d can occur in a series of 2 steps, as shown here, where E is another chemical that is acting as an intermediate. What would the equilibrium expressions for both elementary steps each look like? What about the equilibrium expression for the net reaction? Let's take a look. For our first one, it would be concentration of E times concentration of C all over concentration of A times concentration of B. For a K for the second step, which I'm going to label K2, it would be concentration of D cubed all over concentration of E times concentration of B. And then the net reaction would be concentration of C times concentration of D cubed all over concentration of A times concentration of B squared. You'll notice there are some things that are similar and some things that are different. For example, in the net, I do not see the intermediate E. But the parts that I do see, the C, the D cubed, the concentration of A, those were in numerators or denominators for those elementary steps. There must be a connection between the elementary steps and the net one. Specifically, the connection is that if you know equilibrium constants for elementary steps, or perhaps a series of reactions that can be combined together, like we would for Hess's law, then to find the net equilibrium constant, you multiply the 2 equilibrium constants. If you look back on the previous page and you multiply K1 and K2, you'll notice the concentration of E that's in the numerator of one of them cancels the concentration of E in the denominator of the other, and leaves behind the appropriate numerators and denominator. Please note, if you had to manipulate a reaction when you are doing this combining, then when you do the multiplication, it should be by the altered equilibrium constant that you need. For example, if you double the reaction before adding it together with others, then the k that you're putting in for this multiplication should be the k squared, not the original k before you did your alteration. That's it for now, guys.